Okay, so for this example, we know the second derivative. We're supposed to find the original function f of x. Again, we're going to unpeel the layers, the derivative layers one at a time. And because they give us some extra information, we are also going to be able to figure out the value of any constant, such as c or d, etc., that may normally arise when you find an antiderivative. We're going to be able to find those values. All right, so let's go one step at a time. One time antiderivative, which is going to give us from second derivative, we're going to go down to first derivative, right? And the antiderivative of negative 2x is negative 2x squared over 2 plus 3x plus c. Simplified a little bit, the 2's cancel, so negative x squared plus 3x plus c. And because they gave us, let's use one of the values they gave us. They said if f prime of 1 is 5, so that means if I plug in a 1 into here, if I plug in a 1 and set the whole thing equal to 5, so plug in x is equal to 1. So that's what I'm going to do. So plug in a 1 everywhere you see an x, negative 1 plus 3 plus c is equal to 5. And negative 1 plus 3 is 2. So we got 2 plus c is equal to 5. Subtract 2, so c is equal to 3. So that means I know my prime function without any constants. Now f prime is equal to negative x squared plus 3x plus c, but instead of c, I'm going to put a 3 in there. Okay, because we just determined that. To get to the original function, unpeel it one more time. So take the antiderivative of f prime, that will give you f of x. So term by term, take the antiderivative, which will be negative x cubed over 3 plus 3x squared over 2 plus 3x plus a constant, which I'm going to call d at the moment. And let me see, what was the given values? They said f of 0 is 9. All right, so if I plug in x equals to 0 into this, I need to set the whole thing equal to 9, and that will help me determine the value of d. So 0 for x makes it easier. Everything is 0, 0, 0 plus d equals to 9. Therefore, d is equal to 9. And with that, I can rewrite the function f of x. And all I'm going to do is take it from this step and go ahead and plug in what the value of d is. And since d is equal to 9, all I need to do is erase the d and put the 9 in there. So that is going to be the final answer. So this question, they gave us a second derivative and they asked us for the original function. And with some additional information, we were able to do that. And we were able to determine any constants that arise from anti-differentiation process. You will see some, it's another example, very similar. Second derivative is given. This one, I would say, definitely take your time to do it. In a moment, I'm going to show you the answer, but I would like for you to try it first. As simple as these appear, there's always, a learning curve, little mistakes can happen. So by doing another example on your own, you are making sure that you're understanding it. And if there's any mistakes made, you're going to learn from it and not make the same mistake on a quiz or test. So please take a moment right now. All right, I hope that you got a chance to try this on your own. And here I'm going to give you the answer. It's going to be a very similar question to the one from the last page. You take the antiderivative first. That's going to give you a plus c. To determine that, use the first information, f prime of 1 is 4, meaning that you plug in a 1 for x and set the whole thing equal to 4. Once you get the c value, you put it in, and over the same process one more time, right? You take the antiderivative, and from there, so now that you know the function f prime, this is the antiderivative, 1 by 1, right? Then you add another constant. To figure out what that constant is, you go back to the information they gave us. F of negative 1 is 2. So you're going to plug in negative 1 everywhere you see an x and set the entire thing equal to 2. So this is what we got from there. Plugged in 1 into f of x and set the whole thing equal to 2. There are some fractions that's a little bit messier, but nonetheless, you can combine them and then subtract from 2 to solve for b. And it turns out to be 85 over 6. And don't forget, at the end, you're expected to rewrite the entire function with no constants in it, with the a, b, c, etc. being placed in the original function so that you know the answer. The only to be x and everything else just numbers. And finally, I'm going to give you a quick hint on a problem like this. This one is a little bit different. If you have the second derivative, which is equal to 6x plus 4, f of 1 is 8 and f of negative 1 is 4, determine f of x. So the main difference here is that they didn't give you like f prime of 1. They said f of something and then f of something. That's a little bit different than the last example. Step number 1, find the antiderivative just like we found in the past for the function 6x plus 4. So here I'm going to give you a quick hint. So the antiderivative of 6 is 6x squared over 2, or 3x squared. Antiderivative of 4 is 4x plus c. But there is no f prime, right? So at the moment, keep it as it is. So from here to get to the f of x, you need to anti-differentiate 1. 3x to the 3 over 3. 3x to the 3 over 3. And the 3's cancel. So x cubed. The next one will be 4x squared over 2. And 4 over 2 gives you a 2. So 2x squared. And the next one will be plus the constant. But what is the antiderivative of the constant with respect to x? Since we don't know what c is, let's assume it's a constant and find the antiderivative. And that will give you c times x. So that's the antiderivative of c, right? C times x. And then yet another constant should be added to it, which will be, let's call it d. Okay, so that's the antiderivative of f prime. And now we have two unknowns, a c and a d. Okay, but now we can use both of these initial value conditions. So if f of 1 is equal to 8, in this equation, go ahead and plug in 1 for x and set the whole thing equal to 8. So that's what I did in the line below. Plug in 1 everywhere I see an x, and then set the entire thing equal to 8. So you can have 1 plus 2 plus c, because c times 1 is c, plus d, which was already there, and the whole thing equal to 8. So now you have 3 subtracted from 8 will give you a 5 on the right-hand side, and c plus d on the left-hand side. Notice you have one more initial value condition. F of negative 1 is 4. So now go back to f of x, and where you see x, go ahead and plug in x equals negative 1, and then you're going to set everything equal to 4. Okay, so let's do that. Come here, plug in negative 1. So negative 1 to the third is 1, plus 2 times negative 1 squared is 2, plus cx is going to be negative 1 times c, and plus d. All of that should be equal to 4. All right, so plus d is equal to 4. So if you simplify it a little bit, negative 1 plus 2 is positive 1, and subtract 1 from both sides. So you're going to have a 3 on the right-hand side. So negative c plus d is equal to 3. So we had this equation and this equation. So two equations with two unknowns. You may remember this from college algebra or pre-calculus, how to solve that. You write them one underneath the other, and you can use the elimination method. With the elimination method, you can try to add the two equations, or sometimes you need to multiply it with something so they end up with opposites. So when you add them, one of the variables will cancel. In this case, we don't have to multiply by anything because you have a plus c, you have a minus c. If you add them, it's going to be 0c, right? The c's will disappear. 2d is equal to 8. So we're adding the two equations, add the c's and the d's and the constants. The c's cancel. 2d is equal to 8. So d is equal to 4. Now that we have that, we can also go back and figure out what c is. If d is equal to 4, go into either equation, say over here, and plug in d is equal to 4, and you're going to have negative c plus 4 is equal to 3, and subtract now 4 from both sides. negative c is equal to 3 minus 4 or negative 1, and multiply both sides by negative 1, c is equal to 1. So now we got the other constant. And with these two constants, we're done because we're going to go back to our equation f of x, and we're just going to replace all the constants c and d with their equivalents that we determined. So this one was a little bit unusual because we couldn't get rid of that c early on. We had to carry it with us all the way till we get f of x. So just put the c and the d in place in the equation for f of x. So c is 1, d is 4. So our final answer then is revealed. All right, so it's not a difficult concept as you can see, but it will take a lot of practice to be really good at this because the rest of the class depends on anti-differentiation, just like the first half depended on differentiation, so we could do all the applications. Second half will depend on anti-differentiation and its application, so very important that you start with a solid foundation so we can build on it.